Good morning. This is our notes. The front page says factoring by grouping, and this factoring by grouping method is often used when we see four terms, and that's when we would know to factor by grouping. On the back of this sheet, which is the focus of this lesson, is factoring trinomials. So that means we have three terms. If we have three terms and a quadratic, meaning we have x squared as part of the polynomial. In fact, x squared would be the highest degree polynomial, or monomial within the polynomial. Then we know we should try out factoring using this method. There's several other methods that we'll talk about in the future. So we're going to end up with two groups, just like we had on the front. In each of these problems, the a they're first of all written in standard form, ax squared plus bx plus c. Remember, that's called standard form. And in each of these problems, a equals 1. So we can apply this method when a equals 1. So we know these two terms are both going to be x, since we multiply those together to get x squared. And then the term that goes here, or the value that goes here and the value that goes here, need to multiply together to get 21. So I need two numbers that multiply, two numbers, I'm going to call them m and n, multiply to get 21. And they have to add together to get 10. So this is where knowing your multiplication facts can be helpful. Sometimes I make a little chart to see, okay, what two numbers multiply. First I want to think about they multiply to get 21. Then I want to think about they add to get 10. So two numbers that multiply to get 21, I'm thinking of 3 times 7. If I add those together, they equal 10. So that was my first try. Worked out. So 3 and 7 go here. And now I have factored this trinomial. I'm going to skip 12 since I wrote in that space. I'm going to jump to another typical trinomial that we can factor. I've got p squared plus 3p minus 4. Again, I'm going to set up my two groups of parentheses, putting p in the first spot, and I need something that multiplies to get negative 4. So my m times n, those are my two random numbers that are going to go here and here, multiply to get negative 4, and they add to get positive 3. They add to get this b value. Remember, b is the coefficient for that middle term, and c is the constant. That's the last element in standard form. So what two numbers multiply to get negative 4 and add to get 3? So we can try, let's see, what multiplies to get negative 4? 1 times negative 4. 1 plus negative 4 would be negative 3. So that doesn't work out. But I'm close. I'm just a sign away. So let's try negative 1 times 4. Negative 1 plus 4 is 3. And I could have guessed that one earlier on, since I know that when I have two numbers that multiply to get a negative number, one needs to be negative. And if they add together to get a positive number, the smaller of the two should be negative. So there's a little hint in knowing right off the bat that maybe I shouldn't have tried 1 times negative 4, but negative 1 times 4 would have been a better option. So then I fill those in, negative 1 and plus 4. And that's my factored form. I'll do one more. So let's try 18. So 18.
Excuse me, students, those of you taking the ACT practice class with Mr. Carmelo, you are to report now to the class. Please report to your ACT practice class. Everyone who is signed up for that, please go to class now. Thank you.
All right, so I have, again, I'm going to set up my groups. K goes in the first spot, and I need these two numbers. One's going to be let's see, Nope, they multiply to get a positive and add to get a negative. So then I'm thinking, okay, what multiplies to get a negative or multiplies to get a positive and adds to get a negative? It has to be two negative numbers. So I'm thinking 54, I'm thinking 6 times 9, and both of them have to be negative. A negative times a negative is a positive. And then negative 6 plus negative 9, that's negative 15. And that worked out, first try. So minus 6 and minus 9 are the values that go in. I have my factored form. Now we have a couple problems in this where we have the special case where there's only two terms. So trinomial doesn't even apply. What's this called? This is a binomial. This is a special case where it's of the form a squared minus b squared. Anytime you have a perfect square minus a perfect square, it always factors in to a plus b, a minus b. So we have to match this up. What's the a squared in this case? A squared is k squared. So if a squared is k squared, what's a? Well, we take the square root. What's the square root of k squared? It's just k. What's b squared? 4. If b squared is 4, so if b squared is 4, what's b? Square root both sides. b is 2. And now we have everything we need to just insert these into my factored form. So we would have k plus 2, k minus 2. So if you can recognize this pattern, these are actually the easiest kind. I'll do one more. R squared minus 25. Perfect square minus perfect square. So you need to know your perfect squares. We have a plus b, a minus b. We know r goes here. And then with 25, if b squared is 25, b is the square root of 25, which is 5. So we do plus 5 here and minus 5 here. That leaves you with one more to practice on your own. Now keep in mind, we will do more practice with this, and if you'd like more practice, just come and see me and I can give you lots of extra practice. This is factoring trinomials and some special binomials.